So again, completing a square. We're going to take a problem that looks like this and then turn it into something that looks like this. So the reason for this is that we can take the square root of the first bit here and we can apply the completing the square process. And that is doing this. And what we're going to get is a solution for x. So when we do this, this is going to become x plus 7. We should end up with plus c minus 49. And we can work this down and get, well, I'm trying to look at the steps here. Let's actually do it with a number instead of c. Let's call it 1. Okay, so if we go back and instead of that, we replace that with a 1, that'll make it a little more concrete. So we take this and we turn it into x minus 7 squared. And when we multiply this out, just to show you what it looks like, x minus 7, x minus 7, which is x minus 7 squared. I'm going to do my FOIL method. I'm going to get x squared minus 49x plus 49. So what we need to do here is take away this. I'm sorry, this is 14x. I don't know what I'm on this morning, guys, but I'm not on top of it because it adds to be this. When we get it, we get x squared plus minus 7x minus 7x minus 49. And we add those together to get this. Okay, so this looks sort of similar to what we have here. But we have this 49 instead of the 1. And when we have the 49 instead of the 1, we can do this. This is still a valid thing for us to write. But we have to take away something to make it 1 again. So that's where the negative 48 comes in. When we write this, we have to subtract 48. And then this equals this. They're the same thing. Because what we have here is x squared minus 14x plus 49 equals negative 48. So we have created this so that way we can write this. And we create that. We're looking for perfect squares, things that are numbers that are squared. 1 squared is 1, 2 squared is 4, 3 squared is 9, so on and so forth. Well, we know 7 squared is 49, and we know 1 plus 48 plus 49. So we take away that 48 again, and we just magically appear. We create what we need. So once we have all this, sorry, I know I'm a little messy. Okay, so once we have this guy, sorry, minus 48, then we can take this, and it looks like this is the process that they want us to do, is go from this down to this. That this part is called completing a square. So I believe unless there's like an equals 0 or something like that, then this would be our answer. So I know that's probably not exactly helpful on how you do it, but this is kind of what you're aiming to do. let me pull the worksheet back up. Okay, so if we work through one step by step, I'm going to work through number 3. Number 3. And it requires it step by step. So I'm just going to kind of do some exploration, and then we'll go through some formulas and things to make this easier. So if we're trying to complete the square on x squared minus 12x plus 27 equals 0. And we're trying to solve this at the end. So the first thing we need to do is write the equation to complete the square. So let's find that. It should be in your lesson. Let me look at your lesson. Okay, so this is kind of the format that these quadratics are going to follow. A squared plus b squared, or ax squared plus bx plus c equals 0. So we have our coefficients are our a, b, and c. So if we take b over 2 squared, that will give us what we need to add to the end of this. So I promise this is going to come together more and more. So if we take b squared, we're going to take this negative 12. I'm sorry, b over 2 squared. So this is going to give us negative 6 squared, which is going to give us 36. So this is the completing the square formula. This is the part that you are looking to write down in the first block. So this will give us our C value. And our C value is the thing that we add on to the end. So we've got 36. So when we do this, x squared minus 12x, I'm going to do plus 27 minus 36. Let's see if that works. If you can't tell, I am a little bit out of practice on completing a square. Yes, unless I'm mistaken. I know you're supposed to aim for 36. So what we're aiming to do here is turn 27 into 36. We're trying to take this and we're trying to say, okay, well, what added or subtracted from this will give us 36? So it doesn't look like we do the subtract 36, but we do add something to get 36. So if we have 36, if we say, okay, this is going to be 36. Well, we need it to be actually 27. So if we subtract 9, these combine together to give us 27. So we haven't really changed anything, we just rewrote it differently. So once we have this is factorable. We can take and break apart 36. We're just kind of putting these in parentheses, saying, okay, 36 is 1 times 6, and we're looking for things that can equal negative 12. 2 times, I'm sorry, 1 times 36, 2 times 18, 3 times something, 12. We're still not at things that equal 12. So what we're going to need to do is go all the way down to 6 times 6. So you just keep trying these out until you get to 6 and 6. And 6 times 6 is 36, and it's going to give us 12 if they're both negative when we add them. So if we say negative 6 plus negative 6, negative 12. So we can break this apart. We can say x equals, nope, not x equals, x minus 6, x minus 6. And this is the factoring process that we learned on Monday. This is step 3. So x minus 6, x minus 6 minus 9. And or we can do x minus 6 squared, same thing, minus 9. And we've still got our equals 0 from up here. I just haven't been writing it. So this should be what you get at the end of the third box. So if there's a couple of ways that we can solve this, and the first one is just by doing what we did before, like with the regular factoring. If we, because what we're looking for is the values of x that could equal 0. So if we plugged in something for x, what would equal 0? So I'm just going to plug in some numbers and see what works, and then we'll talk about the process to get down to actually work it out every time. So if we plug in 0 for x, well, x minus 6 is going to be negative 6. Squared is going to be 36. Minus 9 is going to be 36 minus 9. So if we plug in 0, we're going to get 27 here. Well, I mean, maybe we plug in negative 10. I don't know. So negative 10 minus 6 squared minus 9 is 247. So we're not getting any closer. So maybe we try positive 6. So we plug in positive 6 and we get a negative 9. Okay, so we are getting closer to 0, but we're not exactly seeing any pattern here. So if we take this, and I have the answers pulled up in front of me, but getting to them is the challenge. So we can factor this normally, which if we do that, it looks like this. So we take and we break 27 apart. We say 1 times 27, 2 times some fraction, 3 times 9 sounds right. 3 and 9, if they were both negative, we would get a 12. So I'm going to break this apart using these numbers. This becomes this and this. So now we factor by grouping. So I'm going to take out of the first part, I'm going to take an x and end up with an x minus 3. And here I'm going to take a negative, looks like just -1. Oh, I didn't write down my 7 here. Okay, never mind. I'm going to take out a -9 here. X plus 3. So now we take what's in the parentheses, and they stay together. We write it down here. Then we take what's not in the parentheses, we put it down here. So this is our factored form. So looking at this, we know that our solutions, if this equals 0, remember how we talked about if there's a multiplication problem, this has to equal 0, this has to equal 0, or they both have to equal 0. So we can figure out where each of these equals 0. We can say, okay, well, if we plugged in 3 for x over here, then we are going to get 0 on this side. So we can say, all right, 3 is a solution. And then over here, if we plug in, we're going to, the same way, we're going to get 9. So these are what go in box 4. So, 2. Okay, so all it really wants you to do is find C, and you find C using this formula here. So if we work number 2, we're going to plug in B, which is going to be 16. So B over 2, which is 16 divided by 2, which is going to be 8. 8 squared is going to give me 64. So 64 is going to be my C. Okay, feel terrible. Hate this.
Good thing you did the whole worksheet. Now, the numbers you really do some of these big questions.
The worksheet is not 3 questions.
Ours is. That's only what printed out. That's your printed out. That's what I'm typing in.
There's 6 questions. Okay. Well, all it is it's just like number 3. The last one that I just did, they're the exact same.
There's another one. How many questions are there?
6. But they are all like number 3. There are 2 like, there's 1 and 2, and then there's number 3, and then the rest of them are like number 3.
You said that number 3 was the hardest one.
Yes, number 3 does require the most steps. Okay, so the steps on number 3. Let's talk about them. If I can scroll down. Do what?
It says solution X.
For what?
Number 3.
Yes, we solved for, it was 3 and 9, I believe.
Okay, I'm trying to figure.
Those were the last things that we ended up with. Okay, so let's look at this and talk about how to do each one. This is 3, 4, 5, and 6. So if we write the equation to complete the square, we need b over 2 squared. That's usually going to be the same no matter what. So this part, the second box is going to be us taking our b value, whatever it is, and plugging it into this formula. So now this part is going to be the factoring part, where you actually have to use your c value to factor the equation. And then right here is just the solution part where you write the answers down. You should get answer-ish here, and all you have to do is convert it into numbers for the fourth box. So if we had b equals 12, then we're going to get 36 here, and we're going to do that by 12 over 2 squared. And then here, we're going to actually add that to the end of our problem, whatever that looks like. Okay, so if y'all have questions on this, you can email me throughout the rest of the week, but we are going to move on. Okay. So, the quadratic formula. This is, I think, what most people dread when they think of quadratics. This is what most people think of. Quadratic formula, in my opinion, is the easiest way to deal with any of this stuff. It's way easier than factoring. It's way easier than a lot of things, and it works most of the time. It is long to remember, though. It's long to remember, though. It is not a short formula. Negative b plus or minus the square root of b squared minus 4ac. And there's no way around knowing this. There's, yes, plus, just write it like I did, and I'll explain what it means in just a second. So this formula is used with a, b, and c for, like I said, ax squared plus bx plus c. When you have something that looks like this, you're taking your coefficients and you're plugging them into this formula. And what it's going to give you is it's going to give you two answers. It's going to give you an answer for x, and it's going to give you an answer. It's going to give you two answers for x, because when we factor something like this, we get answers that will solve the equation. And we're going to do this with the quadratic formula without ever factoring. But usually we get 2 when we factor. But the quadratic formula gives you 2. And the power of that comes from this sign right here. It's the plus minus sign. And what this means is you have 2 problems, but the only difference between them is the plus or the minus. So one of them has a plus and one of them has a minus. So if you wanted to duplicate this and think of the quadratic formula like this. Then that will work. It's however you want to envision it, but I think it's easier with plus minus because it's the same formula. All the letters are the same, all the numbers are the same, all the signs are the same. But the plus minus means just divided into 2 problems, one of them with plus, one of them with minus. So if we work an example with this, let's work the one that we just did from the previous section. Let's work this one, and then we'll do work number 1. So we've already found that the solutions to this problem are -3, or I'm sorry, 3 and 9. So 3 and 9 are our solutions. Let me copy this, and we'll take it down there, and we will do that via the quadratic formula as well. Okay. So if we have this, and we are plugging in our values, we say, okay, our a equals 1 because it's the coefficient of x squared. B equals -12. and C equals 27. So now we have what we need to plug into this formula. So I'm just going to go through and start writing. Negative 12. Plus minus the square root negative 12 squared minus 4 times 1 times 27 all over 2 times 1. Okay, so this is long, but it's not difficult. There's nothing hard about this. You all know how to handle this. So if we handle this first part, we're going to end up with positive 12 plus minus the square root of 144 minus 4 times 27, 108. This 144, when you take the square root of, or when you square anything, it becomes positive because you're multiplying it by itself. So if you take a negative times a negative, you're getting a positive. So all that is over 2. Okay, so 144 minus 108. We end up with 36. So 36. We know that 36 is 6 times 6. So the square root of 36 becomes 6. 12 plus or minus 6 over 2. Y'all with me so far?
Yes, sir.
Okay, so with the plus or minus, this is the part where you can't do anything else without dividing it apart. So now it becomes 2 problems, one with a plus, one with a minus. 12 plus 6 over 2, 12 minus 6 over 2. So 12 plus 6 is 18 over 2, should give you 9. 12 minus 6 is going to give you 6 over 2, which will give you 3. So these are the same answers we got before, and we did it without factoring. So if you struggle with factoring, like a lot of people do, I know, the quadratic formula works for a lot of stuff that you would have to factor otherwise. It works for pretty much anything you can factor.
Do you think they'll care if we do the quadratic formula instead?
I think they will care if they specifically tell you to use another way. If they just tell you to find the solutions, then I think the quadratic formula will work. Going forward in the future, quadratic formula will probably work most of the time. So in future math classes that you take, maybe the quadratic formula is worth remembering because I think it's easier than factoring if you don't have the intuition for factoring. So let me download the task and we'll do a couple of example problems. Let's do number 1. Negative x squared plus 9x equals negative 4. So one thing about the quadratic formula is you have to have everything all on one side. If everything's not all on one side, you can't use it. So our negative 4 isn't on the same side. So what I'm going to do is add it across. Plus 4 plus 4. And what that's going to give me is plus 4 equals 0. So now I can use my quadratic formula. So what I'm going to do over here is I'm going to write my A, B, and C. And I legitimately do this every single time. Like after a couple times, you're going to be like, this is dumb. I'm not going to write A, B, and C. I still, to this day, do this every single time. A is going to be negative 1, B is going to be 9, and C is going to be 4. So now we plug into our quadratic formula, which is negative b plus minus the square root of 9 squared minus 4 times negative 1 times c, 4ac, over 2 times a. And now we just go to working it down. So we have negative 9 plus minus the square root of 81 minus, looks like plus 16 over negative 2. So 81 plus 16. I'm going to move a little, but I will come back when you get there. So when we work this, negative 9 plus minus the square root of 97 over negative 2. So this is one of the situations where we can't break it down much further. Okay, so when we go to break this down and divide it into two problems, it's not going to go anywhere because the square root of 97 is some ugly number. It's going to be like 9.848, stuff like that. And that's not exactly helpful to us. This is much cleaner. So what we're going to do is leave it like this. And the reason for that is because it is cleaner. If this number breaks down, if it turns into, like if it's 36 or 100 or something like that, that you can take the square root of and get a whole number, break it down into two problems and get a number apiece. But if you can't, then leave it like this. If the square root does not break down, leave the plus minus and everything all together. So this would be the solution. It asks for two solutions on number 1. So what you can do is write negative 9 plus root 97 over negative 2 as your first one, and negative 9 minus root 97 over negative 2 as your second one. What's up?
Why'd you keep your 4 positive and instead of minus 4?
Because what I did is I brought it over here to the other side. So you have to have everything all on the same side to do the quadratic formula. So that's the problem, right? So when we add 4, we're getting it all on the same side. So this is going to cancel, and it's going to become 0. And we're going to end up with this, which is the format we need it in. We need everything on one side equals 0 to do the quadratic formula. So now that we have that, we write down our A, B, and our C, and we plug in. And then we get these two answers. And these are two answers, even though it's only written as one. It's just written to save you writing time. Okay, let's work number 4. And some of these are factorable and some of them are not. So the quadratic formula works even when you can't factor a problem.
Can you scroll back up, please?
I'm sorry. Sure. Tell me when you're done. Okay. So let's work number 4. Number 4 is 7x squared plus 10x plus 5 equals negative 3. Okay, so in this scenario, we have everything on one side except the negative 3. And the rules to do quadratic formula are that you have to have everything on one side equals 0. So this does not equal 0, so we need to add our 3 across. So when we do that, we're going to get 7x squared plus 10x plus 8 equals 0. Now we identify our A, B, and C. 7, 10, and 8. They're all positive. You have to take your signs with you. So be aware of that. If you do have like a negative 7 right here, it can't just be 7 down here. It has to go with it. Okay, so now the quadratic formula. Negative b plus minus the square root of b squared minus 4ac all over 2a. And there's 1,000 different ways to remember this. There are songs that some people remember it by. I just remember it by memory, just by memorization, but there's 50 ways you can remember it. So if you struggle to remember this, look up ways to remember the quadratic formula, and there'll be 50 things that come up. So now we plug in. So -10 plus minus the square root of, I'm going to put it in parentheses, -10 squared, because we are squaring. Sorry, that's not negative. It just needs to be 10. If this were negative, I encourage you to always put this in parentheses because it will help you remember we're taking the square of whatever b is. So if you have a negative here, it's going to come out differently than if you have a negative out here. So minus 4 times 7 times 8 all over 2 times 7. So pretty simple to work. We do -10 plus minus the square root of 100 minus 4 times 7 times 8 is going to give us 224 all over 14. So 100 minus 224. So that gives us -124. And this brings us across a pretty interesting situation. We can't have a negative square root. And we talked about this when we went over complex numbers. Does anybody remember what happens when we have a negative square root? Or why we can't have a negative square root? Any ideas?
It's times itself.
It's times itself. You're close. I know what you're going for. So when you have something square root, it's saying, if you have 36, it's saying something 6 times 6 equals 36. So when you get square root of 36, you get 6 because of this relationship. So when you multiply, if you had -6 times -6, then you're still going to get 36. But if you had a negative on the right side of or on the left side over here with -36, there's no way you can get that by combining 6 and 6. They have to have the same sign, and if they have the same sign, it's always going to come out positive. So there's no way to have a negative square root. But we do have a way to deal with that, and it is complex numbers. And really, this trick is going to make complex numbers significantly easier for you. You do -10 plus minus I times 124 over 14. All I did was I turned that negative into an I, and I brought it to the outside. And you can do that every time there's a negative under a square root. Just make the I, think of turning the I in, or turning the negative into an I and bringing it to the outside. So once we do that, we know how to work this. Just treat I like a variable, treat it like X. So if we have the square root of 124, I don't think that's going to work. It doesn't break down very far. So when we answer this, we can just leave it like this. There are a couple of ways that you can break things like this down a little further, but we haven't gone over them so far, so I don't really expect your teacher wants you to do them unless she wants you to learn more than we have learned in the entire class so far, just about this type of stuff. I think the quadratic formula is useful specifically for a lot of this stuff. And if you're struggling to solve something on your test or whatever, do it by the quadratic formula. It will probably work. So these are your solutions, and you have 2 of them. Remember your plus minus. So that gives you 2 solutions. Okay, let's look at what is in 3.05. Actually, how far are we from the end of this week? I think we're pretty close. Not quite. Focus on quadratics. Oh, 05? This is 05. Is it not? Nope, it is not. Okay, I was clicking on 3.06. 3.05, analyzing quadratic equations. Oh, this isn't that difficult. It tells us what types of solutions we have. The discriminant is this part of the quadratic equation. You take the square root of, actually you can just do the inside. You don't even have to do this. Excuse me. You don't even have to do the square root. So this is the formula for the discriminant. So if we do that for a problem, then what we're going to get for the value of the discriminant on this one is negative 124. You get it in the process of doing the quadratic formula. And it tells you things about the equation. If, let me write it out, b squared minus 4ac. Okay, if the discriminant, I'm just going to do dis is less than 0. So if we get a negative number, then we have two imaginary solutions. That just means that they have I in them. So if we scroll back up, this is the case that we got right then. If this is negative, then we get two solutions with I in it. So if we wrote these two solutions out, we would end up with I in both of them. And if we worked that out and got it in the and put it in the calculator, we would get some decimal times I. If the discriminant equals 0, then we have one real solution. That would be the case where if we worked this out and we got something like, we got 0 here. So if we get 0, we say, okay, negative 10 plus or minus 0. Well, it doesn't matter if you add or subtract 0, you're still going to get the same thing. So you're going to get the same thing for both of these solutions. So you're going to get one number solution. It's going to be one real solution. That's what it's called. Negative 124. Okay, so when the discriminant is greater than 0, you end up with two real solutions. So this is just some analysis we can do without even working the quadratic formula. We can just look at the quadratic, plug it into this little thing, and then all of a sudden we know a lot about our answer. We know what it's going to look like generally. We know, knowing this can tell us if it crosses the x-intercepts or exactly where it works. So if we have one real solution, or I'm sorry, two imaginary solutions, we also know that there are 0 x-intercepts. If we have one real solution, we know that there is one x-intercept. And for two real solutions, there are 2 x-intercepts. So, by finding this, we can determine exactly what our x-intercepts are as well, which this is pretty much all it wants, is it wants the number of x-intercepts and then the types. So number 1, it wants the value of the discriminant, which all you do is you plug this in, which is just part of doing the quadratic formula. It wants the number of solutions, which you can get from this right here. And it wants the number of x-intercepts, which again you can get from this right here. We have it written down. And then it wants the types of solutions. So for types of solutions, we can look, and that's imaginary, real, or real. So you can just fill that stuff in just by plugging in for the discriminant. I mean, it's literally plug and play. You follow the same rules, you get it ready for the quadratic formula, and then you plug the discriminant in. So we are going to call it quits today.